0. Negative 3. That's right. It's down there. It's at that point. So that's negative 3. And I had to show my work or explain how I determined it. So used graph f of x. That's fine. G of negative 2. What would that be? G negative 2. Yep. Okay, so it's positive 3, right? Negative 2 is going up to 3. So it's at 3. Again, this is I use the graph g of x. Questions? We good or no? So negative 3 and 3. Yep. So now we plug it in to this. So that is 3 times p of 3, which is 4, plus f of 0, which is negative 3, times g of negative 2, which is 3. Follow order of operations, so I got to do multiplication before I can add. So that's 12 plus negative 9, which is 3. Part C. If f of x is greater than or equal to 0, then what must be true about the graph of f of x? Then state the intervals on which the graph of f of x is greater than or equal to 0. Okay, so the best way to answer a question like this is to start with like the stem, kind of like you learned how to do a complete sentence back in elementary school. You would start with if f of x is greater than 0, then the graph of f of x, of f of x must be what? If it's greater than or equal to 0, where does it have to be on that graph? If it was greater than, where is it in relation to the x-axis? Above. And if it's equal to, where is it? On. So that's what we say. It must be on or above the x-axis. Then state the intervals on which the graph f of x is actually greater than or equal to 0. Okay. So remember, it's f of x. Look at f of x. We're going to look at where it is greater than or equal to 0. So if I highlighted that part, or those parts, it would be there. Now remember, when I write down an interval, it's the x's. So reading from left to right, What's the first x I start with? Negative 6. Very good. Does it include negative 6? Yes. So I have negative 6, comma, and then it goes to what? No, because down here it's not greater than. Negative 1. Does it include negative 1? Yes, because it's on or above. And negative 1 is on the x-axis. Okay, then we have a union. Oops. And where does it start now? 3. Does it include 3? Yes. And where does it go? Yeah, there's an arrow there, so that means it keeps going. And infinity you cannot include. So it looks like that. I'm going to try to finish part D as much as I can. I might be able to finish it, might not. Obviously, the homework for day 4, you need to do it. I'll put it on Google Classroom. My homework is always going to be due on a Monday by 8 a.m. So really, that's, hopefully you get it done before then.
So
it won't be this Monday.
You turn it on. You turn it on virtual?
Yes, you take a picture of it on Google Classroom. There's a place for it, and you turn it in that way, and that's what I'll grade. Good question. Okay, so for this, sketch a possible graph of a function h of x, which satisfies each of the conditions below. H of negative 5 is undefined. So I don't know where it is. I'm going to leave that blank for right now. It's probably going to be an open circle or something. H of 2 is 5. So that means I go to the right 2 and up 5. There's a point there. The range of h of x is from negative 3 to 5. So it cannot go below here, and it cannot go above here. It can include here, but it cannot include negative 3. H of 0 is 3, so I put a dot at 0, 3. H of 4 is 2, so I put a point there. H of negative 3 is 0, so that's negative 3, 0. And h of negative 1 is 1. The domain is negative 5. Again, doesn't include that. To 4. So it's going to stop here at the 4. It's increasing from negative 5 to 2. So down here, there must be some kind of open circle at h of negative 5. It's undefined, can't be included. And it increases until I get to 2. Should be like that. All of those are increasing. Sorry? What about 6? Oh, that's a 6 in it. Oh, sorry. There we go. All right. Then from there, it's decreasing from 2 to 4. So it looks like that. And that's one way to do it. That's not the only way.